Hello! So in this video I'm going to be demonstrating how to do it's game 2 from PrepTest 33 actually. So this is a page from another book that I have, but this is a real PrepTest game and it comes from PrepTest 33. Okay, so here we have our 6 players are 6 kinds of birds. So I'm going to write out my players first, just the first initial. Okay, there's 6 of them. And we're trying to figure out which ones are in the forest and which ones are not in the forest. So this is an in-out game or a grouping game with only 2 groups. Okay, so those are 2 different ways that you might categorize this game. Okay, and then all of the rules you can see begin with the word if. So we're looking at a bunch of conditional rules with this one. Okay, great. We don't know how many are in and how many are out. So in terms of distribution, that's unknown. Okay, and we don't really have any parameters yet for that. So the rules might give us some insight into what the distribution of the players will be, but at the beginning, it's completely unknown. Okay, so I know all of these things before I even get into the rules, right? Just from writing out my players, reading this little blurb, and then a quick scan of the rules is letting me know that they're all conditional. Okay. So with our conditional rules, we're going to have our triggers on the left side, and then we're going to have the consequences on the right side. So for the first one, our trigger is H being in the forest. So I just have if H to represent H being in. If H is in, then G is not. And to show that G is not, I cross it out. So because this is a conditional rule, I can make a deduction called the contrapositive, which is made by flipping and negating. So we flip these entities or ideas around the arrow, and then we negate them. So G is now over here, but it's in rather than out because that's the negation, right? So it's not out, therefore it's in. So if G is in, then H is out. That's my deduction for that first rule. If jays or martins or both are in the forest, then so are harriers. Okay, sorry. So I'm just have a little. Maybe that'll be better, and I won't hit that bar anymore. Sorry. Okay, so if J is in or M is in. Now, the word or in the LSAT is always inclusive. Okay, so that always includes both. So A or B includes the possibility that we have both of them, right? So this is just assumed. In everyday language, we use or in 2 different ways. So the inclusive way and the exclusive way. Okay, which is A or B, not both. So like I said, in our everyday usage of the word or, we sometimes use it to mean the inclusive version, and sometimes we use it to mean the exclusive version. But on the LSAT, we are always going to assume that it's inclusive unless they specifically tell us that it's exclusive by using the word not both, phrase not both. Okay. So there are definitely other LSAT videos explaining the difference between these 2 usages of the word or. So if you are confused by that, you can definitely just search in YouTube for inclusive versus exclusive or for the LSAT, and you're sure to find a video or 2 that will go a little bit more in depth into that difference. But for here, I'm just going to show you that really we only need to have J or M as the trigger rather than having J or M or J and M. And the reason for that is that if J is in, we don't even need to know whether or not M is in. J being in is enough to trigger H to be in as well. Okay? All right, great. So now we do the contrapositive. So we negate H, put it on the other side of the arrow, negate all of the elements of this, which means negating J, changing the or to and negating M. Okay, so when we negate or, it becomes and. When we negate and, it becomes or. So if H is not in, then neither J nor M is in. And that phrase, neither J nor M in that case, but I'm going to write out just using A and B. So neither A nor B means the same thing as not A and not B. Okay, it does not mean the same thing as not A or not B, right? So a lot of people get confused by that. They kind of take the or in nor and just translate it to an or. That's not how that works, okay? So that's not logically consistent. These two are logically consistent. Neither A nor B means both of them are out, okay? So really, really important to understand that distinction. Also, good to understand that not both means that one or the other is out, okay? So we know not both of them are in, so that means at least one of them is out. So we could have A out or B out, or, right, again, we have it including the possibility that both of those things are true, right? So either A is out or B is out or both of them are out. So the phrase not both includes the possibility that neither of them are in, but in order to fulfill not both, we only need to know that one of them is out, okay? So that's at least one of them is out, therefore we don't have both of them in. Okay, so if you have questions about this, if this is confusing, please let me know. Like, please comment. This is something that comes up quite a lot in my tutoring. So yeah, it's definitely something that confuses a lot of people. Don't worry if you don't get it straight away, but it is important to understand these distinctions. It's really going to help you a lot. All right. So I'm going to stop here with this video, and then I'll continue on with the rest of the rules in a moment.